Thank you so much, Doris. Thank you for inviting me to speak at the Humanities Festival. It's one of my favorite events in Chicago. It's very much of an honor to be here. I lead Studio Gang Architects. We're an international practice of architecture and urbanism, but located here in Chicago. Chicago is our home. Many of the people at my office are hailing from all parts of the world. We have a very diverse group from everywhere, but also from Chicago as well. And I think that part of that diversity is where we get our strong ideas and diverse views. We've created this kind of collaborative zone in the office where no idea is thrown out. Ideas are valued no matter where they come from. And so it's kind of the connection between the place of the office and our studio is very important to our process of working. We divide about evenly with chromosomes, but so many times people ask me, what's it like to be an architect and woman architect in this all-male field? But in our world, it's pretty balanced, just like the world at large. So tonight I was going to talk about our work through the view of technology. And I think with an emphasis on the fact that technology in architecture happens in three different areas. One is really the tools that we use to create designs. So there's technology in those tools. There's also technology in the building itself. So for example, in a curtain wall or some aspect of a building, in the renewable energies that a building uses. And there's also technology in how the building is constructed. And so when you see the work tonight, I kind of go through all those different parts interchangeably, but I think it's interesting to realize that that innovation is really happening at all those different levels and different times. And so the future built with bits and sticks is really about, some very high end technology that is being used, but also the fact that in architecture it always comes back to the material and the job site and actually creating these things that you could also innovate at the very low end of the technology spectrum. So to begin with, I wanted to talk about some of the projects that are really where the idea comes out of the material itself. We started out, maybe 2004, we were asked to be in an exhibition at the National Building Museum that you see here. It's part of the Smithsonian Institution. And it was an invitation from the International Masonry Institute. Masonry being one of the most age-old materials you can find. This is an image from some Inca stonework that is incredible in its the ability for it to be connected, and it's very hard to understand how it was even achieved. But stone is always used in compression, has always been used in compression. So loading stone on top of each other, using it in the most basic way, building it up. Pyramids also, same thing, in compression. So our project, when we came into the building, the National Building Museum, we found that the floor in the museum was actually not sufficient to hold up a great amount of weight. It was a wooden floor. And so we automatically knew that our installation in the museum would be something that would be lightweight. So when the Masonry Institute approached us, they wanted to see if we could rethink stone, given today's technologies, and to see what could be done with it to maybe get younger architects interested in using stone, this age-old material. In creating a lightweight construction, there's always a balance between these three aspects. The material, what the material is capable of, the shape of the structure, and the process of making it. And if one of these things gets too lightweight, the other things end up getting bigger. So there's an actual balance between these things. And what we did in this project was to create a stone curtain, an installation in the museum that was actually hanging from the ceiling instead of sitting on the floor. And how we did that was by creating interlocking pieces that you see here. These are very thin pieces, interlocking, so each piece is hanging from the one above it, putting the stone into tension for the first time. This is an image of it. It was made of about 680 different shapes of stone, all cut out on a water jet cutter based on our drawings, using very high-tech digital tools to create it. But you can see how it's hanging from the ceiling above. And to do this, it took a lot of trial and error. And so, you know, one of the things I think about innovation is really not being afraid to fail. And this is a classic example of it, because we didn't know this would work until we got very far into the process. But it started with an urge and a question and a desire, a curiosity to know if stone could be put into tension, given our new tools, given our composites of materials. Would there be a way to do this? So this image is taken from the basement of the IIT lab where materials are tested, and it's actually an aerospace lab. And when we showed up as architects there, the professor was very curious. He hadn't seen architects coming into the basement of IIT before. And we asked if we could try using his machines to pull stone apart. A lot of times you learn more about materials when you break the materials. And so one thing that we like to do at our studio is to break things. But here you can see the different geometries that we were trying for the interlocking stones. We found what was really interesting. The professor told us that the stone would break at about less than 100 pounds of tension put on the stone. And we found up in the upper left, these are our results. Some of the stone that we used and the combinations with the geometry, we were able to get up to 1,750 pounds in tension. And so you can see in the lower left the breaking, and then also testing different qualities of the stones. But in the very old-fashioned way, we still had to build this wood center. It's basically a false work, similar to what you would do when you're building an arch. We needed to build a false work so the masons could go in and have a form to shape the installation to. So in this image, you can see the hangers at the top where the stones are about to be hung. You have the shape defined by this false work. The false work, though, was designed by our office, and we had to design that with computer and in 3 dimensions as well. So this interaction between low-tech and high-tech is constantly going on. Here you can see, this is me on top of the scaffolding, and the master mason, who was very much out of his element there. He'd never built any stone from the top down. He's always been working from the bottom up. But it really, this kind of project really pushed us out of all of our comfort zone, and we really started to make discoveries. The first course here at the top, you can see, is a high-strength aluminum course, and then the stone begins to hang below that. And then there's a silicone, the black silicone in between the two, and that will fill the joints vertically, comes in, and that helps the structure become a shell, which is the shape aspect. So here you can see getting down to the bottom. So it's really pulled out almost like a big curtain, and held down to the ground. It was very flexible too, so people really wanted to come up and touch it, and all of this was a shell structure that would resist the lateral forces. So it's a really interesting project, even though it didn't have any immediate application, I guess, for our work at that moment. But we learned a lot about stone, and we also, this is someone standing in there. The aspect of the beauty of it, seeing the light passing through the stone, it almost felt like we unlocked some kind of secret mystery in this material as well. Usually stone is seen in such opaque, thick pieces. Here it is being taken down. You can really see how thin it is at that point. So it took about 9 months to design this, 3 months to build it, and then it was up for 4 months, and then it came down. Another project that uses technology in an interesting way is this little house in Chicago. It's called the Brick Weave House. And this was a house that we actually recycled and used about 30% of an old 100-year-old stable that was sitting on this site. The only thing that we really did was take down the front 2 walls and replace them with this very diaphanous brick screen. But the screen is about 26 feet high. There's a garden behind it, and it had to resist a lot of lateral movement as well. So here's another view of it. This is over on Race Street in Chicago. And we tried ways to reinforce this brick screen wall. And what was interesting was, in this case, we really tried to have our structural engineer stamp the drawings, and he wouldn't do it. And then we wanted the masons to take responsibility, and they wouldn't do it. So, and structural engineers have a thing, they don't like masonry. So we ended up working through the design and working with an engineer that designs these small ties that are really hidden in the wall. So those little metal things that you see in the image here, and the steel that's in some of the mortar joints were custom designed and fabricated for this project. And then the responsibility of the engineering actually was taken by the manufacturer of the steel ties. This is a view of it at night. You can see how we really were trying to open it more to the street, but to give some privacy, but using the original foundation walls. And inside you get this amazing dappled light that comes through the garden wall. And the owners are interesting. There are a couple ad executives, and they've gotten the house published on a number of different magazines over the last few years. Another project that is about steel. This is one where there was an existing building with an old ballroom inside. It was a former hotel, and when we came in, we needed to connect a couple levels in there, and we basically took the idea of steel, bending the steel, and used that as a guiding force to design the elements that went inside of it. So this one, with different bent steel elements inserted into an existing frame. So, and then concrete. This is the SOS Children's Village Center down on 74th and Parnell. SOS is a not-for-profit organization that trains foster parents, and they created one of the first urban villages in the United States here in Chicago. But they are all over the world. It's a really interesting organization, and we were designing for them this community center for their first urban village. And what was interesting there was we really had to work with donated materials, all kinds of donated materials. And originally we designed it in brick, and then we found out we couldn't get the brick, so we said, why don't we just expose the concrete and show how fluid this material is. Most of the time when you see concrete, it looks like it was stone or something. So we asked the contractors if they could, these little models on the lower right, if they could make it possible to have wavy pour lines. So every time they would pour a new load of concrete in, could they make it in a wavy line instead of a straight line? And they said, oh yeah, we can do that. Because as you can see, it's a very low-tech kind of operation. The guy's standing on top of the formwork, but they can look inside the formwork and they can actually be very accurate about how the concrete is poured in. And so we were able to express this really exciting quality of the material. The owner, the people who were building this at SOS weren't totally sure about the idea, so what we did here was experiment on the elevator shaft before we went to the final wall. So you can see it's a giant-sized test mock-up. And then the final project. And so it really kind of preserves that fluidity that the concrete has in an interesting way. And what's nice about this, I often say this project had more impact on its neighborhood than a building like Aqua has had, because it really is a regenerative building that the neighbors are really proud of, and it becomes really a hub for a lot of the community activities. So as our work, though, started to expand and move out to different countries, now we're working all over the place and in different places that are all around the world, that some places that we had never even been to before. How do you take this love of materials and technique and craft in a way and apply it to projects in places where you don't know exactly how things are made? And so we started to actually broaden our interest into cities and how cities, because you see the growth of cities so drastically when you travel around. We know that the human population is really exploding right now. I think we just hit 7 billion people on the planet recently, and you see this evidence around the world in the growth of cities. And so that becomes really like, how do we take our interest in technology and making spaces livable to cities? But one thing that you don't always see, and it's one of our interests, is simultaneous with this growth of the human population, we've seen a massive extinction happening with species, plants and animals, at the same time. And we're right in the middle of what's called the Holocene extinction. So what we've been doing at Studio Gang is kind of trying to see how you could intersect our interest with cities and making spaces more compact and livable, but also creating more biodiversity for animals, and so that people can experience these aspects of green spaces, but not monocultures, biodiverse green spaces within cities, and hence create more, a more lively urban aspect. So cities, you can see this shot of Chicago. It's incredible how it sprawls out beyond the borders of the city. And we've been interested in ecologies then, so how to create these two things. And technology, in that a lot of times technology is something that is transferred from one area of study to another. This is an image from a Doppler radar. So Doppler radar usually used for weather, predicting the weather and looking at storms. But in this particular shot, people were surprised to see this pattern, and it turned out that this was actually birds migrating. And so at a certain time, right before dawn, all of the birds take off at the same time, and they produce this amazing pattern on the Doppler radar. So now Doppler radar is actually being used to study migration of birds. So sometimes technology can be used in different ways, and I think that's also interesting in our work. So we look at this intersection between the two. This drawing is of the bird patterns of migration coming up through the Mississippi Flyway and coming through Chicago. And we know that cities, because cities are located on water and birds migrate through places with water, you get this intersection of species, migration, and cities. So one project where we've tried to, amplify the connection between the two is at the Lincoln Park Zoo Nature Boardwalk. This is the pavilion there, but the project is actually larger than that. When we first started the project, we were working with hydrologists, landscape architects, and ornithologists and the people at the zoo to try to take this pond, which was about a 3-foot deep pond that was rather polluted, and convert it into something that's actually functioning as a habitat. So it involved actually regrading the pond, making it deeper so that fish could winter over and the water quality would be improved, redesigning the edges of it. I don't know if anybody knew this, but that pond is actually being fed by Chicago drinking water. So if you think about it, it's such a waste, because you take the water from the lake, clean it up to the level where you could drink it and then put it into a pond. And so one of the challenges was trying to instead take runoff water and refill the pond with the runoff water. But we would have to clean that first, so that the plants actually help us to clean the water. And then at the end, it's, you know, creating the space for people to see all this, the boardwalk path and the pavilion. This was an early rendering of what we imagined it to look like. And then again, with the technology, with the materials, we were interested in wood for this project. We started out looking at boat building techniques to get bent wood. We ended up using, more closely associated with furniture making, a highly laminated with small pieces wood that's bent in 2 directions. So each one of these pieces is small enough that one, you know, person could pick it up and prefabricated, and it all went together just like a piece of furniture. Here's 2 of the pieces in the shop as they're being fabricated and tested. You could see the curvature on the wood in this piece. And then as it comes together, it creates this beautiful pattern with a light coming through the top. And now if anyone goes to Lincoln Park Zoo, this is right at the edge of the migration season, but it's really just buzzing with life. And this has only been open for 2 seasons, but just the change in the water, the change in the plantings have really drawn a lot of activity to this place. There's many migratory birds and even some that are endangered. We designed also a cladding for the underside of the bridge. This is before, and we were trying to create these kind of perches for swallows to build their nests on. They haven't done it yet, but it's starting to be this interesting intersection suddenly between designing architecture for people and designing architecture for biodiversity and habitats. Here's some of the images of it. So think about that city image, the city of Chicago sprawling out. It takes more and more time for kids, inner city kids, to get outside the city. Now we have a place, you know, within the city that can act like this educational and recreational thing. This was an image of Cafe Brouwer before, and then this is how it looks now, today. And I think over the next few years, it'll even grow in more. So it's a very interesting aspect. So part of our work at the studio isn't just doing buildings. We also do research and we teach. Most recently, last spring, I taught a studio at Harvard Graduate School of Design. And I gave the students the most incredibly hard problem, and they came up with some amazing ideas. This is the Great Lakes. A lot of times when I'm talking outside Chicago, I tell people how amazing the Great Lakes are, and I don't think it's recognized. It will be, though, in the future. The Great Lakes are really 95% of all North American fresh water, 20% of the world's supply. So as Chicago sits on the edge of the Great Lakes, it has this great advantage of having all this fresh water. But the problem is we waste it at incredibly high rates. Over 2 billion gallons a day are pulled out of Lake Michigan. Actually, 1 billion of the 2 billion gallons is used just to dilute our sewage before it gets put into the river. But all that water being pulled out, that's glacial water. It's not replenished every year. We return less than 1% of what we pull out. So this is setting up for the students to think about this problem of Chicago's water and the river and issues of invasive species that are actually coming up the river. We know we have problems with our gray infrastructure because we are having flooding in our basements and problems. So we all brag about the fact that we reversed the Chicago River. That's one of our greatest engineering feats. Originally, the 2 watersheds, you can see the subcontinental divide right here, separates the Chicago River and the Great Lakes watershed from the Des Plaines River. And so there actually is a high point between the 2. It's on Ridge Road, in fact. But so it's hard to see, but they were separated before 1900. And then we because of the dangers of polluting our lake water, and also for transportation reasons, there was a massive canal project done about 100 years ago to connect these two watersheds. An incredible infrastructure project, amazing. And basically what was done was they read lines. So taking the stubs of the Chicago River and connecting it over to across the subcontinental divide and moving that water down and out, eventually hitting the Gulf of Mexico. So what we also face, because of that connection, many things happen, unforeseen consequences. One of them is that invasive species started moving their way up the Mississippi River as well as through the St. Lawrence Seaway, and we started to wreak some havoc on the ecology of the lakes, in addition to losing a lot of the water out of the lakes. So I asked the students to think about, could we think about doing a barrier? This really came about with the Natural Resource Defense Council, who is proposing a barrier at Bubbly Creek, and to eventually unreverse the river. So with their help, we did the studio with students to think about the barrier. Could it be more than a barrier? Could it be a bridge? Could it be a connection between these neighborhoods? The invasive species issue is quite important. It's affecting a lot of the industries all around the Great Lakes, not just Chicago, so all the way around. And this is in the Mississippi, the species of carp. There's two that are coming this way, and they're filter feeders, so they're really kind of nudging out they will nudge out other species that are specific to the Great Lakes. So they jump up when you run by your boat, and they're kind of scary, like this lady. But what happens is the invasive species, not all of them, when you make a connection, not all of them can survive in the new habitat. So we were working with a scientist who had a really bad diagram with a bunch of arrows everywhere, and we basically helped to make this more visual, that there's many species, there's only a few that can survive across this ecosystem boundary, but then if one does and they find that they are in control and they find a niche, then you start getting local extinctions of other species. So that's the danger, that's what's basically happening. So we have these compounded problems of the combined sewer overflow. When we have, like today's rain, we would definitely not be able to handle all that capacity in the deep tunnel, so raw sewage goes into the river and into the lake. So it's kind of a mess, and so the students, we just threw all these problems at them. They came up with some great ideas, and these are in the book, the reverse effect book that we were mentioning at the beginning of the lecture, that Studio Gang came up with some ideas about 10 steps to undo this, or 10 steps to a new river. And it's almost like this thought experiment, because we can't unreverse the river in one day. I mean, it won't happen because the water is still polluted. So what could we do? How could we get ourselves to the point where it could be unreversed? So, and then at Studio Gang, we started thinking about, the future river could really be like this place where we use the water, we clean the water, we recycle the water, put it into these inland lagoons, and then recharge the lake with it. That would be the ultimate goal. And in doing that, there's incredible urban potential for new parts of the city. So right now at Bubbly Creek, the city looks something like this, where we have this post-industrial fabric, a lot of vacancy, underused land, and in the future, this could be one of the lagoons where this recycled water is put back into the lagoon and sent back to the lake to recharge it. So these are kind of exciting ideas about where ecology and cities overlap. This all started with a project that we won in 2004 for the Ford-Calumet Environmental Center. They wanted to build a center in Calumet that would be about the heritage of Calumet as a steel producer, but also kind of shed light on the amazing habitat that exists there. You can see the city up in the upper right-hand corner, and the site is down here in Calumet. So it was both, the site was in this area where there were a lot of salvaged material handlers and material dealers, and as well it was on this waterway where migratory birds move through. So all the places with red titles are places where we could find materials to build this building. So our idea there was, would it be possible to build a building, use less energy if it were more like a nest? So in other words, using materials that are abundant and nearby and discarded to create a building, as opposed to specifying brand new materials from around the world. So we followed that through, looking at all the possible materials that we could get our hands on in that area. There were a lot. We did a lot of extensive research on what was there. And we also found that at the same time, there was a problem about the birds moving through urban areas. Buildings with glass are invisible to migratory birds, and something like 93 million birds die every year colliding with glass. That's something we discovered in our office. One of the interns, actually, who was a biology major, found that research, and we decided to address it with an architectural solution. But it is a rather severe problem. I mean, this is one day's collection, the Chicago bird monitors during migration, because birds they're not used to it, not like pigeons that know what glass is. And so it made me really nervous, and all of us really nervous, because we found out that buildings are the biggest killers of birds, so that makes architects like the murderers of birds. And, we had to do something about it. So the design really creates a space for people to watch birds, but also protects them from colliding with glass. These are the elevations. This is a shovel-ready project, by the way. And it's not yet funded. We had about half of the funding came from the Ford Foundation, which is located right across the street from the project. So the idea would be that we found there would be a way to specify materials that are abundant through the techniques of locating material. So basically, you wouldn't be able to do this in the past, but now it's possible to specify material that's available. And so these tools that we have about information can also help us with this. And now about towers. Towers are important for cities also, because we need to find a better way to live in a more compact city. So Aqua Tower, located on Chicago's lakefront, we wanted to think about living in towers. It is our future, because we'll have to make those cities more compact and more livable. Only 100 years ago it looked like this in Chicago. So it is possible to change a city and to make it more inviting. A footprint of a building like Aqua is equal to about 738 households spread out in this about 330 acres in a typical suburb. So, and that directly correlates with the carbon footprint of a household. There's a group called the Center for Neighborhood Technology in Chicago, and they publish this research. We found that we would be able to reduce, if everyone lived in a more compact environment, you would really reduce the carbon footprint immensely. And so it is important for us as designers and architects to study cities. This is an image of the 1933, this is like a WPA map of Chicago showing the Illinois Central Railroad terminus where Aqua is located. And this is a site about 28 acres that Magellan was redeveloping for this project. They started with a plan by SOM, Skidmore, Owings Merrill, who designed a center park, about a 6-acre park in green there, with residential and mixed use all around it. And then we designed the orange part, which is Aqua, and also in addition to the Swiss Hotel and connections to below. So when we started this project, we were really thinking about this, the importance of towers, and we've continued on beyond Aqua to design more towers in different cities all over the world. We really started thinking of it as a place for, to live. How could you make it more interesting, get views and connections? And oftentimes we thought of it like an exciting, almost like a topography, like a mountain range turned upright. In mountains, you can a lot of times get views around corners or things that you wouldn't normally see when you take a hike. And Aqua, this is the elevation of it as a topography. We would create these hills on the facade that would allow you to see around the corner and to see between buildings. And they would be oriented to specific landmarks. Addressing the materials, we found that each of the floors, we could create this topography by thinking of it in layers and strata in different levels. Just like the strata that you find around the Great Lakes, which is shaped by water and wind and time, the Aqua strata would be shaped by our other criteria, which are use and accessibility and solar shading. So what's created is really these outdoor spaces, so people can, instead of being stuck inside of a tall building, you can actually step outside and be part of the city and part of this building at the same time. Because the floors are all different, you have these oblique views to other people. I always found it a little bit isolating to be up in a tower. So what was nice about designing this building was the connection that you have to your neighbors. And then we've heard that it's really been happening, that people are like meeting each other. And yeah, that's pretty low tech actually. And it was a design process that evolved. We started with these criteria, but we also thought about how it worked all together and designed it to flow in and out. This is the actual model of the building. And then we made these overhangs are helping us with the solar, cutting down the solar rays on the building, but we also used different kinds of glass in specific areas that were more high-performing glass. We call these pools, where there isn't any solar shading to respond to the climate. This is a wind tunnel where you basically test your building to see how it responds. And we did find that with the variation in the slabs, we were able to reduce the wind pressure, and it's actually more comfortable for a longer period of time out on the balconies. Those are just the caissons, like 12-foot diameter caissons. But here, the interesting innovation was how to create the different slab ebbs. Every level is different. And so with the builders, we found there was a gauge of steel that could be used, bent into the curvature of the slab edge, and then reused on every other floor. So it's really laid out with a technology very similar to GPS, and then poured and then reused at a later date. This is just a quick little video where you can see how this is done. The big formwork that was just pulled up, those are called table forms. And they make a big rectangle, and then the curve is just laid out on top of that rectangle. So you can see about half of it being poured, and then the other half is being set up for pour. Yeah, it's pretty amazing. And it was the builders, McHugh, were able to build this at 3 days per level, which is another big. It's a very important parameter for tall buildings. They have to be done quickly, because if you think about it, if you just add 4 hours per floor, you're adding up months on the loan and construction loans and so on. So I thought this was a really interesting way that combines the technology of our office, our digital drawings, with technology that exists on the job site to actually build a tower of this size. We also designed the connections between the spaces There's 50-foot difference between the top level of the ground and the park below, so we created some very large public spaces to connect them. And then you can see how this looks at the ground level. I think that the Radisson Blu Hotel just opened recently, filling out the first 15 floors of the building. Then there's apartments, rental apartments, and condominiums at the top. It has a very big roof deck. And like in an image like this, you can see the reflective pools that we called them on the east facade. And here it is from Millennium Park. But it's really, most exciting when you walk by on the street really close to the building. You get this sense of this exciting landscape. And I think just this is a peregrine falcon that one of the contractors sent me a picture that he was taking from the top level. And I think one thing that's really underplayed with tall buildings, we are going to be living in these more compact cities, and there is something that is rather exciting about the buildings, about being on the outside of the building at the high levels. And this was reinforced to me when I received this image in my mailbox one day. But there's people that really treat the city like a mountain range. I mean, they love to climb, and I think it's something that is maybe it's an aspect that it gives. We have an urge to be in these places, and maybe the city is our next mountain range, at least in Chicago. Then I'll wrap up with this project, which is the Hyderabad O2 project. We were asked to design a tall building in Hyderabad, and it's the South Central India, a place that we hadn't really been, so it's kind of called it a tower of brick. We didn't know much about the climate, and we also really learned that our building, which was about 1 million square feet, was just little tiny circle in a much bigger development. So you see this, these emerging cities, entire cities being developed. 1 million square feet was just one small part of it. The site looks something like this, and one thing that's really interesting is this site is very close to a very large high-tech industry. So people that will be living here will be close to their jobs, but at the moment there just isn't enough housing for this population, kind of an emerging class of professionals, and so this development came into being to serve that need. We started to research and basically start looking at what has been done in India successfully. This was a slightly different part of the country, but what they did there that was really interesting was use the buildings themselves. This is a cross-section through the street to shade the street and the outdoor areas. And this is really effective, as well as the courtyards, which help to ventilate the buildings. This is a traditional Haveli building that is naturally ventilated. You can see an image of what the streets look like. So it's all done for an environmental purpose, which is exciting and interesting. And traditional fabric in the city might look something like this. So what our idea was in the experiment was really to see if we could do a taller building, a more modern building that would also take advantage of some of these techniques of natural ventilation. That was our first idea. And so the idea is that there would be a courtyard building, a high-rise about 29 stories, that would ventilate through the center courtyard. And this is called O2, this project, but we really employed the self-shading studies to help us to design how it would work. This is how it looks. It actually ended up being 4 different towers that kind of interlock, with the cracks in between being the places where the ventilation is happening. And what you get in the cracks are these amazing public spaces where people can see each other and have social interaction. So on the right is our model of one of the cracks from the inside with all the balconies, and on the left, the traditional Indian village. And then I think I'll close with just what we learned from doing a project in India, which was learning about masonry, and about 40% of the population in the whole world lives in earthen homes, which is pretty shocking. So basically just taking the material from the ground and creating bricks out of it. A lot of times these bricks, bricks are fired, then they become much more stable material. But what we found in India was that they had a technique using a compressed block with a small amount of cement that did not have to be fired in a kiln. So besides just bringing our knowledge of high-rise and technology to India, we also brought something back, which was, this is IIT's basement again, and we're basically bought an Indian machine to make compressed block. And the reason is, it's a very low-tech machine, but it's very green because you're using the material from the site itself to create the blocks. And there are a lot of people in India that want jobs. So it doesn't have to be a robotic process. It can be a handmade process. And what we did there was start to study, would there be a way of adding another material to the blocks? So working with the materials testing lab again at IIT to see if we can improve on this low-tech end of the spectrum. And so I think in conclusion, the idea that high-tech in architecture is only our digital technology, I think is a missed opportunity, because there is so many lives could be improved and so much to be explored on the low-tech end of the technology spectrum. Thank you very much. I can also take questions too, because we have time for that.
Thank you. What you're doing is just incredible, and it's fantastic. How do the costs of building an Aqua or an SOS, where you change the concrete, how do they compare with conventional building costs?
Well, I think what I learned from Jim Lowenberg, my client at Aqua, was that he really immediately liked the design. We actually showed him 2 designs for the tower, which was at the time called Building P, not Aqua. And he really saw our project for the wavy slabs and the multiple slabs as being something that could be done within the parameters of a tall building. So I think in the end, it added like $1.5 million, something not very significant in the scope of it. But at the same time gave this benefit of allowing people to go outside and use the balconies. So it wasn't a lot in that case. In SOS case, there was a lot of experimentation that probably was, adding cost, but it ended up being something that people in the neighborhood really respect and preserve. So the building has never had graffiti, and even though it's in a pretty, like a relatively tough area, I guess, and so I think design pays for itself. It's hard to say something costs as much as an ordinary building, but it doesn't. It costs more because there's more thought put into it, and there's more design put into it. So you have to believe that the building will give you something back.
If you answered this, forgive me, but the wood at the South Pond project, how did you bend it?
Oh, okay. Let's see, how can I describe this? Think of a corset. Basically, it's laminated wood, so the wood is cut up into very small strips, and then laminated together and put into a press. So basically a metal press with clamps and screws that forces it to be bent. But this wood at Lincoln Park Zoo is bent in 2 directions. So after it went through that torture. It was taken out, cut into the other direction, into more small strips, and bent the other way. And that's what gave us the, so each piece is both creating almost that pod shape, but it's also creating an arch. So that's how it was done. And that's the way that like bent furniture is made as well. Sometimes with bent furniture, they use steam, but we did not have to use steam in this case. Good question.
Some of us may have heard, people heard Walter Hood, an architect from, I guess, West Coast, speak the other day at the Humanities Festival. And I wonder if you would just comment a bit on the relationship or differences between your approach and his approach to design.
Yeah. Well, I think I haven't heard him present recently, but I know Walter Hood's work. I think one thing that we're both looking at, I think both of us are very interested in the disused post-industrial sites and how to bring those back into useful urban fabric. And I was going to show you another project tonight specifically about that, but I kind of ran out of time. But I think it's really one of our biggest challenges right now is to figure out how to clean up those sites, first of all, to make them occupiable. And one technique that's also kind of a low-tech is using plants to do that, like phytoremediation, he might have talked about possibly, to pull some of the contaminants out of the soil. This is something that we proposed for a project in Cicero, Illinois, and I think that's the first step. That could be done, and sites could be cleaned in as little as 4 to 5 years if we were to today start planting the right kind of plants that have phytoaccumulators that could pull those out. So I think it's something we should definitely start. And then how to re-inhabit or settle those areas. Many ideas, we need a lot of ideas. There's huge amounts of area for post-industrial riverfronts like in Chicago. Some places really need to be built back as compact urban settings where people can live, and other places could possibly be green and outdoor spaces, which is probably what he was showing. I think, yes, all of the above. But it's really the biggest opportunity right now, I think, especially for places like City of Chicago to maybe start to accumulate some of that land and buy it up while it's available, and possibly use it to do bigger infrastructural ideas like unreversing the river. Yeah.
Comment and a question right back here.
Hi.
The comment is, it strikes me that you are more than an architect. And the question is, what have been your influences in growing up to be more than an architect?
Well, I see myself as an architect, but I think instead of focusing on the final product of the form, we do focus on that, but I think what we have tried to do is focus on ideas, and the ideas are what lead to the form and what lead to the innovation in the architecture. I think it's just, I have always had just a curiosity about things and materials and breaking things and making things. So that's kind of where that comes from. And I think the influences of where I've studied and who I've worked for have all definitely come into play. But many architects are combining a kind of idea about science and math and then art. I mean, that's kind of like, that's the combo you need for architecture. And I think we're also just in a very exciting time right now because there are so many innovations happening in green building materials and structures, and so there's a lot to figure out and a lot to explore. And so we decided to, instead of just doing building by building, we also want to see how they fit into the bigger context and how they will inform the creation of cities as well. So, but
Okay, we have time for one more quick question.
sure.
Good. You mentioned Cicero.
Cicero.
Could you comment
Yes.
on the reconceptualization of the bungalow and the reuse of industrial structures?
Yes. Oh, and I hope that everyone will get to see the show. We are, the reason why we picked Cicero to look at, and I'm sorry I didn't get to show it tonight, but we were invited to be in a show at the Museum of Modern Art, and will open in February, this coming February, called Foreclosed: Rehousing the American Dream. And the show was put together by MoMA's curator, Barry Bergdahl, and Columbia University, who wanted to kind of take another look at housing. You know, housing kind of public housing became a dirty word in the last year. And so, you know, could we think about housing again, given the disaster of suburban sprawl, and what could be done? So we decided to pick the post-industrial fabric of Cicero. Cicero is a very early suburb. It was founded as a railroad town and a factory town, but now all of those jobs are gone. I think the Western Electric had at one point like 45,000 people working at that one factory. Now it's just abandoned. So Cicero has a lot of opportunity in having this abandoned industrial fabric, and we took that as a chance to think about how we would create a new type of housing that would combine living and working in one place, and also how to kind of close some of the loops on water and materials. So it was a very interesting project. We just completed it. It'll be up in February. But our take on it was really to think about the suburb as this, almost like a new gateway. In the past, you know, the U.S. has always been about immigrants. We're the immigrant nation. We're the immigration nation. And now immigration is really happening in the suburbs as opposed to the city centers. The city centers were always more well-equipped to handle and to integrate and assimilate immigrants, but now this is happening in the suburbs. So how could we create a new kind of urban fabric that would help people get their feet and kind of propel them into the middle class without the benefit of having the factories? And so our solution was to combine living and working in an interesting way, and hopefully you'll be able to see what we came up with there. Okay.